In this video, we're going to take a look at exponential functions. This is section 13.1. So before we take a look at exponential functions, we're going to review exponents and properties of exponents. So what is an exponent? So basically, an exponent is a shorthand way to write multiplication of the same number over and over again. So for example, 2 times 2 times 2 times 2 times 2 can be written as 2 to the power of 5. Okay, so on the calculator, if you wanted to evaluate what 2 to the power of 5 is, there's a power key, and it's the same in scientific. So you would have 2, the little caret key is to the power of 5, enter is 32. So that's what we get when we take 2 and multiply it by itself 5 times. Reviewing laws of exponents, you don't have problems in this section where you have to simplify exponential expressions. I just want to review them so you have a little bit better understanding as we go through the chapter. So just a reminder, review of laws of exponents. If you have a to the power of m times a to the power of n, you add the exponents. So example, x to the 8th times x to the negative 3 means we add the exponents. 8 plus a negative 3 is equal to x to the power of 5. Okay, same with number 8, 5 times s to the power of negative 5. That's 5s to the power of 1 plus a negative 5, which is equal to 5s to the power of negative 4. So that's just a review of how to, when you multiply, you add exponents. When we divide, we subtract exponents. So if we have x to the 5th divided by y to the negative 2, oh gosh, we can't add or subtract exponents because those are not the same variables. So that can't be simplified anymore. But if we did have something like x to the 8th divided by x to the 3rd, we would take x to the 8 minus 3, which is x to the 5th. Okay? So that's not simplifiable. All right, so that's subtraction. Then, if you have a power to a power, it means to multiply the powers. That's a to the m to the n means multiply the powers. Okay? Or if it's in parentheses, a times b to the power of n, it says take each item inside the parentheses to that power. So our example over here on the right, we have something in parentheses cubed. So you would take each individual term, including the numbers, you would take 3 and cube it, x cube, and then y to the negative 2 and cube it. And we would end up with 3 cubed is 3 times 3 times 3, which is 27. X to the power of 1 squared, or cubed, is 1 times 3, which is 3. Y to the negative 2 cubed means multiply. We get y to the negative 6. Okay. Then same thing if we're dividing and have something to a power. You take everything on the inside to the same power. So 29, this example, is taking everything to the power of negative 3, except for the 3. So I would have 3 times a to the power of negative 3 over b to the power of negative 2 to the power of negative 3. That gives me 3a to the negative 3 over b to the negative times a negative is a positive 6. So the 3 could be written in the numerator with a to the negative 3, or it could be written out front. So that's just a little bit of a review. Also remember that anything to the power of 0 is equal to 1, and a to a negative power makes a fraction, not a negative number. A to the negative power equals 1 over a to the n. So an example of that, one of our answers over here, we ended up with 5s to the negative 4. That could also be written as 5 over s to the 4th, because s to the negative 4 is 1 over s to the 4th. Okay, so just a review. And that will make, when we talk about them in the next sections, just kind of keep in mind what those properties are. All right, so the first item we're going to take a look at in this section is how do you evaluate an exponential expression with the calculator? 2 to the 5th we could evaluate with or without a calculator. It's multiplying 2 by itself. 4 times or 5 times. But if we have something like 3 to the power of square root of 5, we're going to have a calculator for that. Or 1.5 to the power of pi. Remember that pi is equal to approximately 3.14. But we're going to use the pi key in the calculator to get it to as many digits as possible. E, if you don't know what E is, it's the Euler number. It's approximately 2.72, and it goes on forever like pi does. So we're going to use the calculator to estimate. And the key is really to not round anything. So 3 to the power of the square root of 5, you would take 3, the power key, to the power of the square root of 5, and then hit enter. And it says we want these to 3 significant digits, so that would be 11 point, oops, let me get the calculator back, 11.665. So it helps if you have a calculator that you can type these in directly. Next one, 1.5 to the power of pi. Find the pi key on your calculator. Mine is right above the exponent. There's my pi key. Notice if I hit enter, it doesn't just round it to 3.14, it rounds it to a lot more digits. So I'm going to take 1.5 to the power of pi, not just 3.14, because I'll get a more accurate answer. So I get about 3.574. Try these on your calculator to make sure that you know how your calculator works, because there's a whole lot of different types of calculators. Next one, I have 2 pi to the power of negative e. So I'm going to type 2, use the pi key, not 3.14, to the power of, now I'm going to put parentheses to make sure that that negative is included with the e. The e on my calculator is right above the division key. And then close parentheses. So 2 pi to the power of negative e is about 0.089 to 3 significant digits. And last, we have 2e to the power of negative square root of 2. So we have 2. Oh, and notice there's parentheses around there. There's parentheses here too. What did I forget? So up above, let me go back here. Backspace. This 2 pi is in parentheses. So let me show you what the difference is. There's 2 pi in parentheses to the power of negative e. So this is really important, and it almost caught me right there. That's a completely different answer. So what happened is, in the first one, when I typed it in, it was only taking negative e pi to that power, not the 2. So order of operations, if it's in parentheses, it means it wants us to take both the 2 to the power of negative e times the pi to the power of negative e. So the second one is correct, so be really careful with the parentheses. So this is 2 pi to the negative e, which is not the same as 2 pi in parentheses to the negative e. That one we ended up with 0.007 to 3 significant digits. So careful with parentheses. Okay, last one. We want to make sure we put the 2e in parentheses because we're taking that entire expression to the power of negative square root of 2. So I've got parentheses 2e, there's the e, to the power of, I'm going to put parentheses around it, negative square root. I'm not used to dealing with these types of numbers. Oops, let me go back here. I think that'll be okay. So we get approximately 0.091. Okay, so that's a little bit of practice. These are irrational numbers, they're not integers. and taking them to powers. Okay. So next one, this is a problem from homework. It says evaluate the exponential function for the given value of x. Y equals 216 to the power of x if x equals negative 2/3. So this is asking it in a slightly different way. We're looking at it as a function, 216 to the power of x to the power of negative 2/3. So again, you want to use the calculator, and it's really important in this case to make sure that we put the parentheses around the negative 2/3. So we have 216 to the power of parentheses negative 2 divided by 3, and that makes sure that we're taking it to the power of negative 2/3. And we get approximately 0.02. We want an integer or a simplified fraction. Oh, well, that's a decimal. So how do we know that that decimal can be a fraction? Okay, a couple of ways to think about this. So what you can do with your calculator, you can take that decimal and make it a fraction. So that would be 1/36. Or you can think about what we're doing to 216 to the power of negative 2/3. So since that's to the power of negative 2/3, that really means 1/216 to the power of positive 2/3. That's one of our exponent properties. So if you take a look at 216 to the 2/3 to the power of parentheses, because it's a fraction, 2 divided by 3, that gives us 36. So that's how come the denominator ended up being 36. So that's 1/36. So a couple of ways you can think about that. So just be careful. If they want a simplified fraction, you can use the fraction key on your calculator, or you can take an extra step to think about what does 216 to the power of negative 2/3 really mean. All right, now that we've worked with exponentials, we're going to take a look at exponential functions. And an exponential function is in the form y equals some base b to the power of x. And in the first example in your book, it talks about what things are exponential and what aren't. So y equals 3 to the x is exponential, but negative 3 to the power of x is not, because the base is negative. However, y equals negative and then 3 to the x is an exponential because it's negative 1 times 3 to the x. So any real number multiple. Okay, so that means if you can write it in the form a multiple times b to the x, then that's also exponential. But what we're saying is this base b right here has to be positive. Okay, so also y equals the square root of 3 to the power of x is exponential because it can be written as 3 to the power of x over 2. As long as x is a real number, so is x over 2. So there will be a couple of questions on homework that ask you if it's exponential or not. All right, how do we graph an exponential function? So let's take a look at y equals 2 to the power of x. We're going to plot some points just so you can see how it works. So the first point, when x is negative 3, y is equal 2 to the power of negative 3. Remember, negative powers make fractions. That would be 1/2 cubed, which is 1/8. To the negative 2, 2 to the power of negative 2 is 1/2 squared, which is 1/4. Negative 1 gives us 2 to the power of negative 1, which is 1/2. 2 to the power of 0, anything to the power of 0 is 1. 2 to the power of 1 is 1. 2 squared is 4. Oops, 2 to the power of 1 is 2. 2 squared is 4. And 2 cubed is 8. So the points are plotted on the graph over here. So notice, for negative values, we didn't get a negative answer. Our y values are always positive. So what happens on this side is they keep getting smaller, but they never cross the x-axis. They're always above. So in this case, if it's approaching the x-axis or approaching a horizontal line but never actually touching it, in this case the x-axis is called a horizontal asymptote, asymptote. So that's a line, the equation of a horizontal line that your function approaches but doesn't actually touch. It doesn't always have to be the x-axis, it could be up, depending on where the graph of your exponential function is. On the positive side, when we keep putting in higher and higher values of x, y gets higher and higher, greater and greater. So that goes on and on forever to positive infinity. Y's just keep getting bigger. So the basic features are, if we were to look at the domain of this function, the domain is all values of x. So the domain is all real numbers. You can put anything you want to for x. But what happens with the range is you only get out positive numbers for y. So y is greater than 0 for the range. The x-axis is an asymptote of the graph. It's a horizontal asymptote. And then as x increases, b of x increases if b of x is greater than 1. What does that mean? Our value here, 2, we're taking 2 to the power of x. 2 is bigger than 1, so our function increases. If our function would have been y is equal to 1/2 to the power of x, then these would all be reversed. Our function would look like this instead. It would be the mirror image. Okay? And in that case, it's a decreasing function if b is less than 1. If this value right here is less than 1, then your function is decreasing from left to right. If it's positive, above 1, it's increasing from left to right. Okay? So that's basics about what exponential functions look like. Last is a word problem. We have the value v of a bank account in which $350 is invested at 7% interest, compounded annually, is given by the equation below, where t is time in years. Find the value in the account after 6 years. So we're going to substitute a 6 in our equation for time t. So this is one of those instances where you don't want to take 1.07 to the 6th, round it, and then multiply it by 350. What you want to do is put it all in the calculator at the same time. So we have 350 times 1.07 to the power of 6. And then round at the very end. Round to the nearest cent. So we end up in our account having $525.26. If your calculator isn't like mine where you can put it all in, another way you can do that is to take 1.07 to the power of 6, find the answer but don't take it off the screen, and then multiply that times 350.